In this video, we are going to talk about how to classify angles within a circle and the arcs, and then use properties relating the angles and arcs together. So first off, a central angle. So a central angle is an angle whose vertex is on the center of the circle. Okay, so the center of the circle needs to be the vertex of the angle. That's going to be the central angle. Okay, so this part right here is the central angle. Then the intercepted arc, okay, is between where the angle ends. Okay, so the angle starts at A, goes to B, ends at C. So the intercepted arc is between there. Okay, and so central angle, intercepted arc. Then when the vertex of the angle actually gets pulled out to the edge of the circle, that's called an inscribed angle. Okay, so an inscribed angle has its vertex on the edge of the circle instead of on the center. So if we put some letters here, if we did A, B, C, D here, okay, so starts at A, ends at D, starts at A, goes to D, ends at C. Okay, so here's your inscribed angle. The intercepted arc is again between the ends of the angle or the rays of the angle. So here's your intercepted arc. Okay, difference here is that the vertex of this angle is on the edge of the circle, not the center. So inscribed angle versus central angle. Central angle is on B, the vertex is on B. Inscribed angle is on the outer edge of the circle. So when we're doing angles, so the central angle, what's important here is that the central angle's measure is the same as the intercepted arc. Okay, same as the intercepted arc. So you'll see in this picture, we've got this red central angle. Okay, and then the intercepted arc is the same measure as that. Versus the inscribed angle is half the measure of the arc. Okay, so for central angle, you have angle equals arc. Where inscribed angle, okay, you have that the angle, oops, let me change colors here. You have that the angle equals half of the arc, or what I also like to say is that the arc is double or 2 times the size of the angle. Okay? So when we're taking a look here at measure of angle ADB, so ADB is this red angle. Okay, so this is the red angle, ADB. So you'll see that that's labeled as 100 degrees, and that's a central angle since D is the vertex and the center. So then the measure of angle ACB, so this is the blue angle. And then we have the measure of arc AB. So let me jump to arc AB first. So remember that AB is the same as the central angle. Okay, so this red angle is the same as this arc. So the degree measure of that arc is 100 degrees. Okay, which makes sense since a circle is 360 no matter how big the circle is. So right here is 360 degrees and here is 360 degrees. So it's proportional. So this 100 proportions out to that edge as well. Okay, so this arc is 100. So then what's this inscribed angle? So remember an inscribed angle, remember that the angle equals half of the arc. And we know that the arc in this case is 100 degrees, same as that central angle. So this angle is equal to 50 degrees. Okay, which then also helps you to see that if you take the angle, double it, you get the arc. So angle times 2 is the arc, or arc divided by 2 is the angle. Then this is just telling you that if you know different parts of the arc, you can add them together if they're right next to each other. So let's say that this one is 80 and this one is 200 degrees. You can just add those together to get the whole arc. So then if we wanted to figure out how far it was from A through B all the way to C, we would just add those. Okay, so the measure of ABC on this example that I have would be 280. You just add those two arcs together. And then remember that the total of the whole circle is 360. All right, so let's take a look at some examples. So feel free to pause the video and try these first and then come back and listen. So the measure of RTS. So RTS, this is an arc, okay? It's got that little arc above it instead of an angle here, which the angle is then going into the circle. So arc RTS, so that's here, R through T over to S. Okay, RS is a diameter, so this arc is 180 degrees. It's exactly half of the circle. How about arc TSR? So remember, you start at the first letter, go through the middle, and end at the next letter. So TSR is going this way. So let me get this purple line out of here. Okay, so TSR is this way. Remember, the entire circle is 360 degrees. So this goes from here over to here, plus that 110 would make it all the way around. So we'll just do 360 minus 110 to get 250 for this one. And then arc TR, 2 letters, so we know it's the short distance. We know it's the smaller than 180 degree arc. So this one is 110 degrees. Then angle, TPS, so angle, so TPS wants this one. This is a linear pair with the 110. They make a straight line, and remember, a linear pair is 180 degrees. So we'll do 180 minus 110 to figure out this little piece as 70 degrees. And then RPS, so angle RPS. Well, that's a straight line, so that angle is going to be 180 degrees. Next one, so arc AB so we need to find arc AB, so we're going to have to figure out these angles first. Okay, so remember, arc AB is going to be the same as its central angle, okay? The angle that goes into P and starts and stops at AB. Okay, so if we can figure out this angle, that's the same as this one. Okay, or you can look at that this is a semicircle here. Okay, and a semicircle is 180 degrees. And we already know that this piece is 140. So for this one, we could do 180 minus 40, minus 140, sorry. Okay, 180 minus 140 to get 40 degrees for AB. Okay, so this AB right here, let me change that to purple for us, okay, is 180 minus the 140. Okay, so we get 40 degrees here. Then BCD, so BCD, so this one right here, which really should not have 3 letters, right? It should only have 2. So I'm just going to cross one of those off. So BD, since it's less than 180, should only have 2 letters. Okay, and if you take a look at this one, we see another diameter here. So we see a diameter here. So this is a semicircle. So then this one and the 40 should total 180 again. So this one is 140 as well. And then how big is CD? Okay, so just from C to D. Okay, so remember that we've got from here to here is 140. How big is just this piece? Well, if these 2 angles are the same, then these 2 arcs are the same as well. So this one here is 40. Okay, and 40 plus this should be 140, right? Because B all the way over to D is 140. 40 of it is used up here. So this needs to be 100. Okay, or 140 minus 40. Then DPE, okay, let me get some of this stuff. Whoops, let me get some of this off of here. Okay, so what have we figured out? We've figured out that this is 40, this is 40, this is 100. Okay, and now we need to figure out DPE. Okay, so DPE is this angle right here. Notice it's a vertical angle with this one, so these two are the same amount. Remember, a central angle is the same as its arc. So this arc right here is 40 degrees, which means that this angle is also 40 degrees. So then this angle, this vertical angle, is also 40 degrees. Then CPA, notice, is two of these angles. Okay, so you see the two arcs in there. Okay, so CPA would be two of those 40s, okay, or 80 degrees. And then this one is an angle, DE, that's a bad notation for that one too. So this should be the measure of arc DEB. I know because E isn't on the inside of the circle, so this should have said the arc. So DEB all the way around here. So you have 40 plus 140 plus this arc, which is the same as its central angle, 40. So 40 plus 140 is 180. Plus 40 again is 220. All right, then let's use it with some algebra. Okay, so set up an equation and solve it. So take a look at this picture. So one thing that I'm noticing right away in this picture is the diameter. Okay, and so remember that a diameter will create a 180-degree angle within the circle and a 180-degree arc. The other thing that I'm noticing is this central angle. And remember that the central angle is going to be the same as the intercepted arc. Okay, so this is 53. This is 53. You could also say this arc is the same as this angle, so you could put the 6x plus 7 in there. Either way, you should hopefully notice that those two together total 180 degrees. Okay, so you've got that arc on the outer edge, that's 180, whoops, or the angle on the interior, this one, as 180. So 6x plus 7 plus 53 equals 180. Combine your like terms, so 6x plus 60 equals 180. Subtract 60. Divide by 6. And you get x equals 20. Another way you could have done that problem is just figuring out this angle right here. So you could have done 180 minus 53 right away, and you'd have gotten 127 for this angle right here, which then would be the same as this. So you could have set this equal to 127 as well. Either way will get you x equals 20 if you do it correctly. Looking at this next picture, so we see that we have this arc here as 7x. Okay, I see that I have this arc here as 10x minus 12. And then we've got this angle here, which is 32, which would be the same as this arc out here. Central angle equals the arc. So what I notice is I've drawn this whole circumference, okay, or the whole edge, all three arcs of the circle totals the whole circle. So remember that the arcs of a circle total 360. So I'm just going to add up all of these arcs. And I know that what they total is 360. So that will set up my equation for me, and I'll be able to solve. So then combine your like terms. So 7x and 10x is 17x. Negative 12 and positive 32 is positive 20. Subtract 20 from both sides, and you get 17x equals 340. Divide by 17, and we get x equals 20. Okay, two more theorems and then a couple more examples. So in this one, it's just talking about that if you have a right triangle inscribed, meaning all the vertices are on the edge of the circle. If you have a right triangle that's inscribed into a circle, automatically this hypotenuse has to be a diameter. Okay, and the reason for that is that these two legs make an inscribed angle, right? Because the vertex is on the edge of the circle, and this intercepted arc right here. So if this is 90, then this has to be 180 because it's double the angle. And 180 means exactly half the circle. So this AC has to be a diameter every single time. And then for a quadrilateral, if you have a quadrilateral inscribed, meaning all the vertices are on the edge of the circle, these opposite angles here are going to be supplementary. So angle F plus angle D always equals 180, okay? And angle E plus angle G is always equal to 180. Okay? So opposite angles are supplementary if the quadrilateral is drawn inside of a circle. So let's take a look here. Okay, so figure out what type of angle this is that we've learned about. Okay, and this one is an inscribed angle. Okay, because the angle goes across and touches the circumference here. Okay, so this angle's vertex is on the edge. So remember, if you have the angle and you want to get the arc, you double it. Okay, so the angle doubled equals the arc. So 32 times 2 is 64. Okay, here we've got arcs over here, and we've got this inscribed angle. Okay, so inscribed angle. So if I head this arc relates to this angle. It's double the angle. So we need to figure out this arc. Okay, and we know that the angles that the arcs of a circle equal 360. So we can do 360 minus 104 minus 28 to figure out this arc. Okay, that's missing. So 360 minus 104 minus 28 gives us 228 for this arc. So then this angle, to get the angle, you divide the arc by 2. So we would get x equals 114 degrees when I divide by 2. Okay, next example. So I look for the number. So I see this number in here. So I'm just going to kind of highlight that. Again, this is an inscribed angle. Then I've got two variables. Well, I notice that the x variable is the intercepted arc of this red angle. Okay, so remember, angle to arc. So the arc is bigger than the angle. It's double the angle. So if I double that, I get 50 for x. Okay, or for that arc. So the x is 50 degrees. Then I notice that my y variable, I'm just going to highlight this angle here that the y is in, because that's what I'm looking for. So notice that this is an inscribed angle from this arc. So we've got this arc inscribes this angle. So remember, to go from arc to angle, you divide by 2. The angle is half of the arc. So y is 25 degrees. Next one, we've got an inscribed angle again. Okay, and now this one has algebra in both pieces, so it's a little harder to just say let's double or do half. So I like to say 2 times the angle equals the arc. Okay, so if I multiply the angle by 2, it equals the arc, right? That's what we've done here. 25 times 2 equals 50 is what we did. So let me just write it out one more time so you can see it. So 2 times the angle equals the arc. So in this case, we'll do 2 times the angle, which is x plus 4, equals the arc, 4x minus 10. So distribute the 2 in, so we get 2x plus 8 equals 4x minus 10. And then we need to get our like terms together. So I like to get the x's together first. So I'm going to subtract 2x from both sides. So 2x minus 2x is 0. So 8 equals 2x minus 10. Add 10 to both sides. And we get 18 equals 2x. Divide by 2, and you get x equals 9. All right, last three examples using these inscribed polygons. So remember, okay, so look, we've got a quadrilateral inside of a circle with all the vertices on the edges. So remember what the theorem said is the ones across from each other total 180. Okay, so across from each other total 180. So we would have y plus 68 should equal 180, or you can just subtract 68 from 180. And you'd get that y equals 112. And then x and 82 should equal 180. So again, you can just subtract 82 from 180, and you'd get x equals 98 degrees. Okay, so here you could just do 180 minus 68 for y, 180 minus 82 for x. In this next problem, okay, same concept here, but now we're going to have to do algebra. Okay, so the ones across from each other total 180. So we're for sure going to need to set up an equation here. So with these two across from each other, x plus 2x minus 6 equals 180. And then we can solve. Combine your like terms. Okay, add 6 to both sides. Divide by 3. So you get x equals 62. And then for the y part, we'd have 10y plus 8y equals 180, the angles across from each other. Combine our like terms. Divide by 18, and you get y equals 10. Then in this one, it's a triangle. Okay, so this one is a triangle. So remember that we have, this is a diameter. So this would be 180 degrees. So x would be 90. Okay, so x equals 90 degrees. Remember, if it's an inscribed triangle with the diameter, then you have a right triangle. Now this next part is going to bring back, because now if we're trying to find y, I'm actually just going to draw this out here. Okay, I'm just going to redraw this triangle. So this is 5. We just found out this is 90. Here's your variable. And this is 34 degrees. So this is actually going to do trig. So you need to set up SOHCAHTOA. So here's our angle. This side is opposite. This side is adjacent. So we are going to set up a tangent function. So tangent of 34 equals the opposite over the adjacent. So type in tangent of 34 into your calculator. So 0.6745 equals 5 over y. Set up a proportion to cross multiply. So you get 0.6745 y equals 5. Divide by 0.6745. So 5 divided by 0.6745. And we get x equals 7.41.